Today we will learn the rules of replacement. As you know, we have learned the rules of inference. There we have learned 9 rules. Number 1 was what we call modus ponens. If we have P implies Q and we say that P, then we can claim that Q. P implies Q, P, therefore Q. If you find in any derivation these two lines P implies Q, P, then you can easily write Q and you can cite the rule modus ponens. We find a similar argument which is not a valid argument. P implies Q, Q, therefore P. If we have P implies Q and we have Q, on that basis we cannot say that P. And if we say this, then we are committing a fallacy, and we have named the fallacy on the basis of what we do in the second line. So what we are doing here, we are asserting the consequent and thereby claiming the antecedent. And therefore we have seen the name of the fallacy of affirming the consequent. Similarly, we have seen the rule called modus tollens. If we have P implies Q and we claim that there is no Q, on this basis we can claim that there is no P. Antecedent is also called sufficient condition and consequent is called necessary condition. So if we have the totality of all the conditions which produce certain effect and the necessary conditions are not present, then we can say that the totality of conditions is not present. So P implies Q, negation of Q, therefore negation of P. But on the basis of P implies Q and negation of P, we cannot claim that negation of Q. So if we have line 1, P implies Q, and we say that P is not available, on that basis we cannot claim that Q is not available. What it means, when we say that the totality of conditions is not available, we cannot with certainty claim that the necessary conditions are not available, right? And this you can test on the basis of the truth table, and you will see that in one row you will discover that P implies Q is true, negation P is true, but negation Q is false. And this way we can show that this is an invalid argument, and any invalid argument involves a fallacy. And as you know, in the earlier case, the fallacy is named after the practice which we do in second. So what we are doing in second, we are in fact denying the antecedent. This is the antecedent of the conditional statement, and second line is the denial of the antecedent. So the fallacy is named as the fallacy of denying the antecedent. Then we have also seen a rule, disjunctive syllogism. If we have a statement P weighs Q and we say that P is not correct or P is denied, on that basis we can say that Q is accepted. A disjunction is true when at least one disjunct is true. So if we say that P weighs Q is true and in the second line we say that P is not true, then we can derive that Q is true. So wherever you find these two lines, P weighs Q and negation P, you can derive Q. Then we have seen hypothetical syllogism, which is also a rule. If P implies Q and also Q implies R, then we can say that P implies R. Now consider this particular rule of inference, constructive dilemma. If we have P implies Q and R implies S, and we say that P weighs R, the antecedent of both the conjuncts. The conjuncts are conditional statements. So if we assert in the second line the disjunction between their antecedent, then we can derive a disjunction between their consequent. Then we have seen a rule called destructive dilemma. So first line is the same as you see in the constructive dilemma, but what you do in the second line, these two are conditional statement. Q is consequent in this conjunct and S is a consequent in this. So if we are denying the disjunction of their consequents, then we can derive the disjunction between the denial of their antecedents, right? So this is called destructive dilemma, and you know that this is an extension of the rule of modus tollens. Now another rule is called simplification. So if we say that P dot Q is true, very well we can say that P is true, because you know that conjunction is true only when both the conjuncts are true. So if P dot Q is acceptable, then we can say that P is acceptable. So wherever you find P dot Q, you can write P, a rule of simplification. Then another rule is conjunction. If we have two propositions, we can put them in conjunction. That is permissible, precisely for the reason that if this proposition is true and this is also true, then we can say that their conjunction is also true. And these are valid arguments, which means this cannot be the case that the premises are true and conclusion is false. Similarly, there is another simple rule, addition, and in short you can write addition. What it says, if you have just one statement, you can say that either this or any other statement. If you see P is true, then P weighs Q cannot be false. So these are 9 rules of inference. Now let us learn the rules of replacement. They are basically the statements. So unlike the rules of inference, the rules of replacement are in terms of statements. The rules of inferences are in terms of arguments. The rules of replacements are in terms of logically equivalent statement. You have seen the biconditional, right? The biconditional or logically equivalent statement, or what you call material equivalence. So consider there are certain rules which have two versions. So we have taken first the rules which have two versions. Consider the rule what we call the rule of De Morgan or De Morgan's theorem. Just assume that P dot Q is true and we want to deny that P dot Q. So if you want to deny that P dot Q, you don't need to deny each of them individually. You can say either P is not true or Q is not true. And this way you have said that P dot Q is not true. The second version is the denial of disjunction. So if you want to deny the disjunction, under what condition a disjunction is denied? You know that each of the disjuncts must be false. Only then a disjunction is false. So if you want to deny a disjunction, you have to individually make each of the statements false, right? So negation of P and negation of Q. So you have conjunction between the denials, right? So negation P dot Q is logically equivalent to negation P weighs negation Q, and negation P ways Q is logically equivalent to negation P dot negation Q. And this is called the rule of De Morgan or De Morgan's theorem. So wherever you find in any argument, wherever you find negation P dot Q, you can easily write this part. Wherever you find the occurrence of left hand side, you can easily put right hand side and cite the rule. You have to cite the rule that in this line you are using the rule of De Morgan or any other rule, right? Similarly, if you find this at the right hand side, then you can write the left hand side. So you know that this is a biconditional statement. You have the equivalence, right? So this implies this and also this implies that. Similarly, in all the rules of replacement, in fact. So whatever you see, and the interesting thing is that since these are the statements, so they can be used even in between a very big compound statement. So you can write wherever you find the occurrence of this, it may be part of a big statement, right? So you can replace this by this, or you can replace this by this. A rule called commutation is what it says that if you have either P or Q, you can also say that either Q or P, right? If we have disjunction between P and Q, so either P or Q, it means the same thing when we say either Q or P, and they are logically equivalent. So wherever you find P wedge Q, you can immediately write Q wedge P without any problem, and you can cite this rule, commutation, in short COM. The second version is related to conjunction. So if we have P dot Q, we can easily write Q dot P. So if P dot Q is true, Q dot P also becomes true without any problem, right? Similarly, if P dot Q is false, Q dot P also becomes false. So that way also you can see that they are logically equivalent. So wherever you find P dot Q, you can write Q dot P. Another rule is called the rule of association. So P ways Q ways R. You can associate the components of disjunction. So you have disjunction throughout, in fact, outside as well as inside. So you can easily write P ways Q together and then wedge R. So the rule of association can be applied when we have throughout conjunction. So P dot, if Q dot R are together, we can write P dot Q as together dot R. Only conjunction and disjunction allows this kind of association. Implication, equivalence, etc. do not allow. So only when we have throughout disjunction or throughout conjunction, then we can apply the rule of association as per our requirement. Another rule is also having two versions, the rule of distribution, and here you find among the logical connectives there is a mix. So outside you have conjunction, inside disjunction. This is a simple mathematical rule. We can distribute P inside. So how do we distribute? We can say P dot Q wedge P dot R. Here conjunction is the main connective, but here the main connective is disjunction, and that is the effect of the rule of distribution. Same thing is in its second version. If you have outside disjunction and inside conjunction, you can again distribute this, and the distribution is in terms of P wedge Q dot P wedge R. So if we have P wedge Q dot R, then we can write P wedge Q conjunction P wedge R. Now let us see material equivalence. This is basically simple definition of biconditional. P and Q are biconditional under what situation? When P implies Q and also Q implies P. Similarly, the second version you can see P is logically equivalent to Q Under what situation? Either P and Q both are true, or neither P nor Q is true, right? So this is the second version. First version says that P implies Q and also Q implies P. The second version says that either both are true or both are false. Another rule which has two versions is tautology. Tautology is just repetition of whatever we have. So if we have P, we can easily say that either P or P. So in place of P, we can write P wedge P. Similarly, in place of P, we can also write P dot P. And you know that the value of P is going to determine the value of whatever is at the right hand side. So tautology says that in place of P, we can write P wedge P or P dot P. Or P wedge P, if we obtain P wedge P somewhere, we can write simply P. The remaining four rules have only single version. So this is the rule of double negation. What it means, if we have P, we can write double negation P. And double negation is taken to be affirmation, right? So when we say that it is not the case that P is not true, we are intending to say that P is true. Similarly, another rule is called transposition. It is related to a conditional statement. So if we have P implies Q, in place of P implies Q, we can also write negation Q implies negation P. So wherever you have P implies Q, you can write negation Q implies negation P, or wherever you have negation Q implies P, you can write P implies Q and cite the rule of transposition. Another rule is called material implication. Material implication is again related to a conditional statement, and this also we have discussed. So if we have P implies Q, we can say that either P is not true or Q is true. This we have seen during the discussion on the paradox of implication. So this paradox, the assertion of the paradox becomes a rule, and the rule is called material implication. So in place of P implies Q, we can write negation P wedge Q. The last rule of replacement is called exportation. So if we have P dot Q in parenthesis implies R, then we can write P implies in parenthesis Q implies R. So P dot Q implies R can be rewritten as P implies Q implies R. Now by using all these 10 rules along with the rules of inference, we can construct the proofs of derivation. I will take one example for your convenience. Look at this example. Either he has his old car repaired or he buys a new car. If he has his old car repaired, then he will have to pay a lot of money to the garage. If he pays a lot of money to the garage, then he will not soon be out of debt. If he buys a new car, then he must borrow money from the bank, and if he must borrow money from the bank, then he will not soon be out of debt. Either he will soon be out of debt or his creditors will force him into bankruptcy. Therefore, his creditors will force him into bankruptcy. How do you symbolize it? Suppose you are using a symbol. He has his old car repaired. We can use R as a symbol. So either R or he buys a new car. So let us say N is adopted for the statement which has new car. So this is the symbolization of the first statement. Now look at the second statement. If he has his old car repaired, then he will have to pay a lot of money to the garage. So the antecedent, this is a conditional statement. So the antecedent is this and the consequent is this statement. And you know that you have adopted R symbol for the antecedent. He has his old car repaired, so you are using R, same R. Then this is a conditional statement, so R implies he will have to pay a lot of money to the garage. So let us say garage statement we are taking as G. So R implies G is the symbolization of the second statement. If he has his old car repaired, then he will have to pay a lot of money to the garage. This is the symbolization of the second statement. Now let us see the third statement. What is the third statement? If he pays a lot of money to the garage. This is the first part of the conditional, that is the antecedent here. Then he will not soon be out of debt. This is the consequent, right? So he pays a lot of money to the garage, that we have adopted a symbol G, and G implies he will not soon be out of debt. So he will not soon be out of debt is a negative statement, right? So we have to write negation, and then out of debt we can write negation of B. So he will not soon be out of debt is symbolized as negation of D. Now look at the fourth statement. If he buys a new car, then he must borrow money from the bank. Then we have a comma, and then and is written. After and you find if he must borrow money from the bank, then he will not soon be out of debt. So this is a rather bigger compound statement, and you clearly see that here you have conjunction. So consider from here to here, this is one statement, and from here to here, this is another statement. And these two statements are in conjunction. But it so happens that both the conjuncts are compound statements, and the conjuncts are in the form of conditional statement, right? So we will symbolize them accordingly. So consider the first conjunct is a conditional statement, and look at the antecedent of that conditional. If he buys a new car, then he must borrow money from the bank. So these are two. He buys a new car is antecedent, and he must borrow money from the bank. Let us symbolize this part, number 4. So he buys a new car. For that we have adopted N symbol, right? He buys a new car. So we have adopted N symbol for that. So we are using the same symbol. Once you have adopted a symbol for any statement, the same symbol should be used throughout the argument. So if he buys a new car, then he must borrow money from the bank, right? So this is a new statement. So we have to adopt a new symbol. So I have adopted B symbol for he must borrow money from the bank. And remember, this is one conjunct, and then we have conjunction and. So we are putting conjunction, and then another conjunct. He must borrow money from the bank. This is one, and the second is this one. So the second conjunct has he must borrow money from the bank. For that we have adopted a symbol B, right? Then he will not soon be out of debt. So remember, we have adopted negation of D symbol for this statement, right? He will soon be out of debt is D. He will not soon be out of debt, negation of D. So we have adopted negation of D to symbolize he will not soon be out of debt. So this is the fourth statement. Now fifth statement. Either he will soon be out of debt or his creditors will force him into bankruptcy. So you know, either or is a disjunction, right? And the first disjunct is this, and the second disjunct is this. His creditors will force him into bankruptcy. So he will soon be out of debt. Remember, we have adopted the symbol D to represent this. Immediately you have seen, right? Immediately in the preceding statement, he will not soon be out of debt. We have written negation of D here. So he will soon be out of debt. Either he will soon be out of debt, that is D, or which his creditors will force him into bankruptcy. So let us say forcing him into bankruptcy. We adopt F symbol for that. So this way we have symbolized either he will soon be out of debt or his creditors will force him into bankruptcy. Either D or F. D which F. And then we have conclusion. So we write against the last premise a slash and then the sign of therefore and then symbolize the conclusion. So what the conclusion says? It says, therefore, his creditors will force him into bankruptcy. That means F. We have adopted F symbol for that. So this is the symbolization of this whole argument. Now let us derive the conclusion from the premises. So we have 5 premises and we have one simple statement as conclusion. Now how to move from here? We have to see how we are going to get the conclusion, right? F is our conclusion. Where is the occurrence of F in the premises? It is here, D which F. So if we want to have F, what we need to have from 5, if we can somehow get negation of D, then we can apply a disjunctive syllogism in 5 and then get F. So now we are looking for negation of D. Now the question is how to get the negation of D. That's the whole exercise we need to take up. Now we have the remaining premises. What we can immediately do with regard to any of these premises. Now consider one thing we can immediately do is to have simplification of 4, right? So we can write N implies B, that is 4 simplification. We get N implies B from the simplification of 4. Similarly, we can get B implies negation D this side, and okay, let me explain you how we can get it. So we can have B implies D this side conjunction here. So you know the rule of commutation. Line 4 we have applied the rule of commutation, and now we can use again the rule of simplification and write B implies D. This is in line 7 rule of simplification. So we have got N implies B, we have got B implies negation of D. From these two lines 6 and 8 we can get N implies negation of D. What is the rule? 6, 8 hypothetical syllogism, right? Hypothetical syllogism applied in line 6 and 8, right? So N implies negation of D. Now we got N implies negation of D. We have the remaining propositions here. If you look at R base N, R implies G, G implies negation of D. Now we can reach some kind of relation between N and D on the basis of these 3. If you look at the configuration R, N, R, G, G, D, so certainly we can get some relationship between N and D on the basis of 1, 2, 3. Now let us try to get a relationship. So what immediately we can do in proposition 1, we can apply double negation in R, right? So instead R wedge N we can apply double negation in R. In place of R we can write double negation R, right? So this is double negation in line 1. Now what we can do with this? We can write negation of R implies N. What is the rule which allows this? From 10 we are deriving 11, negation R implies N. So we have applied material implication, right? So we got negation R implies N. Now we have N implies negation D. We have negation R implies N. What we can write here? Quite conveniently, we can write negation R implies negation D. How we can write like that? On the basis of line 9 and line 11. Negation R implies N. N implies negation D. Therefore, we can write negation R implies negation D. What is the rule? 11 and 9 hypothetical syllogism. So we got negation R implies negation D. From here, we can easily write D implies R. Which rule allows this? In line number 12, we have applied the rule of transposition, right? Transposition says that P implies Q can be written as negation Q implies negation P. So here we are moving from right hand side to left hand side. Negation R implies negation D is rewritten as D implies R. Now look at the proposition second. R implies G. We have D implies R, then we have R implies G. So we can easily write D implies G. D implies G on the basis of line 13 and line 2. D implies R, R implies G, therefore we can write D implies G. Line 13 and line 2. What is the rule? Hypothetical syllogism. So we got D implies G. Now here we have G implies negation D. Here we have D implies G. T implies G. G implies negation D. So we can easily write D implies negation T. D implies negation D. What is the rule? We have line 14, D implies G. We have line 3, G implies negation D. So we are writing D implies negation D. D implies G. G implies negation D. Therefore, D implies negation D. In line 14 and 3, we are using hypothetical syllogism, right? Now we have got D implies negation D. What we can do immediately? We can apply material implication in line 15. Material implication. Now negation D wedge negation D. D implies negation D is rewritten as negation D wedge negation D by using rule of implication, material implication. So negation D wedge negation D, this is tautology, right? So we can write just one negation D. What is the rule? We have applied tautology in line 16. Now we were looking for negation D. In order to derive F, we were looking for negation D. Look at this line. D wedge F, line 5, and then negation D. So from here we can derive F. What is the rule? Disjunctive syllogism. D wedge F, negation of D, therefore F. D wedge F is line number 5, negation D is line number 17, and for that we have used disjunctive syllogism. And this way we have arrived at our conclusion, that was F. So this way we do the exercise.